Good evening, boys and girls. It's the 16th of September and we are doing technical sciences again. You know, this is where we meet same time, same place during the week, 6 o'clock up until 7. And it's another lesson for grade 12 technical sciences. We are still dealing with a very important topic, and this topic is organic chemistry. And remember, it is divided into those three parts, and we are still working on nomenclature and ensuring that we will be able to grasp all of the marks in this particular topic. So let us look at how our lesson is going to be today. So in our table of contents, then I show you that we'll still deal with organic chemistry, nomenclature as per the examination guidelines. Remember this section, I'm keeping it in all of the lessons, and we are doing that because I always want to revert back to those definitions that are very important for you to know and how they are stated in the examination guidelines. And we will be working on nomenclature, and we will be doing questions on nomenclature, and I will also be reminding those that have tuned in for the first time how they must prepare for the examination. Right. So this we have already talked about. This is what you find in the examination guidelines. I just want to indicate to you that today we are going to deal with ketones as well as alcohols. And we are also going to deal with alkenes. And we will be looking into the different homologous series there for today. Then this is amongst the definitions that we definitely have to know, and the structures and the names of functional groups, and we are still dealing with that step by step. Then so we are moving from where we have actually left off. Right, so this is still some of the rules that we follow when we deal with IUPAC names. So yesterday in our lesson, we learned more as well about alkenes, right? And with alkenes, you will remember that you see them with a double bond between carbon and carbon atoms. So this is actually the functional group, the double bond there. It's what you look for in the molecule or in the organic compound that then tells you to which homologous series does it belong. So we know that if I see a double bond between carbon and carbon atoms, I know that I am talking about an alkene. Furthermore, we know that with this type of an alkene, because I have a double bond between carbon and carbon atoms, we then remember that it means it is actually unsaturated altogether. Now, what do we mean when we say an alkene is unsaturated? So this butene, it belongs to this homologous series, which is an alkene. And remember what we say about an alkene? We say an alkene is unsaturated. Why are you saying it is unsaturated? It is very simple. It is because it contains double bonds between carbon and carbon atoms. It is because it contains double bonds between carbon and carbon atoms. So you can't now say it contains double bonds and you just stop there. No, you can't. It contains double bonds between carbon and carbon atoms, and that is why we say it is unsaturated. And remember, when we were dealing with alkanes, we said the alkanes are saturated. Why are they saturated? Because they contain only single bonds between carbon and carbon atoms. But that is when we talk about alkanes. In other words, This issue of being saturated and unsaturated has to do with whether you have single bonds or multiple bonds. So because alkanes are saturated, then we say they have, because they have single bonds between carbon and carbon atoms, we then say they are saturated. But because alkenes have double bonds between carbon and carbon atoms, which is then a multiple bond, we then say they are unsaturated. Furthermore, we know that these are also classified as hydrocarbons. So why are we actually classifying them as hydrocarbons? It's very simple. We know it is because they contain only carbon and hydrogen atoms. So these are classified as hydrocarbons. And we know alkenes are hydrocarbons because when you look at the molecule, you can see that it contains only carbon and hydrogen atoms. So we've already talked about that. Now, we've also talked about the general formula, and I will just remind you the general formula, it's simply CnH2n altogether. So all molecules that are alkenes are defined by that particular general formula. They have the same general formula, which is CnH2n, and we can test that general formula. So you can then check, okay, we know that the N stands for the number of carbons. So for this molecule here, the number of carbon atoms is 1, 2, 3, 4. In other words, this will be C4H2, and where I see N, I'm going to put a 4. In other words, this is going to give me C4H8 as the molecular formula. Remember, this one is the molecular formula. So if I go and I count there, I have 1, 2, 3, 4 carbons, and then the hydrogens, if I start there, I have 1, 2, 3, 4, 5, 6, 7, 8. So it means this general formula is correct. And the same applies to this molecule. Can you see that there I have a double bond between carbon and carbon atoms? As a result, I will then know that I am dealing with an alkene. And if I'm dealing with an alkene, then I will definitely know that, oh, the general formula of alkenes, it's CnH2n. So these molecules are both alkenes, so they're described by the same general formula, which is CnH2n. The number of carbons is 1, 2, 3, 4, so it will be C4H, then 2, where I see N, I'm going to put a 4, so this is going to give me C4H8. And if I literally check, I have 1, 2, 3, 4 carbons, and then the hydrogens, if I start there, I have 1, 2, 3, 4, 5, 6, 7, 8. So most definitely, these molecules belong to the same homologous series because they are described by that general formula, which is CnH2n. Right, now we are dealing with isomers. Now, when we deal with isomers, remember now, isomers are organic molecules with the same molecular formula, but a different structural formula. Now, when you look at these two molecules, you will agree with me that this molecule and this molecule, they are all C4H8. This one is also C4H8. So this is the molecular formula, and this is also the molecular formula. Remember, with the molecular formula, all I just check is how many of each atoms are present there. So I have 4 carbon atoms and I have 8 hydrogen atoms. I have 4 carbon atoms and I have 8 hydrogen atoms. So the molecular formula is the same. Now, what about the structural formula? Remember, if they are structural isomers, then the molecular formula between them must be the same. So we are happy with that because the molecular formula is the same. But we then need to check if the structural formula is different. Then I go and I check. If I go and I number my carbons here, this one will be carbon 1, this one will be carbon 2, this one will be carbon 3, and this one will be carbon 4. Are we together? Right. Why is this carbon 1 and this one carbon 4? Why is it not the other way around? Why is this one not carbon 1 and why is that one not carbon 4? We then remember our IUPAC rules, my dear learners, that tell me that the functional group must be on the lowest numbered carbon. So the functional group here, my dear learners, is that double bond between the carbon and carbon atoms, because that's what defines what an alkene is for us. As a result, because the double bond is between carbon 1 and 2, we simply say it is on carbon number 1. So according to this numbering, then the lowest numbered carbon can only be a 1 where the functional group is. So this molecule now has a functional group on carbon number 1. But if I go to this molecule and I number, it's carbon 1, it's carbon 2, it's carbon 3, and this one is actually carbon number 4. So by actually numbering from left to right, I can see that this double bond is between carbon 2 and 3. In other words, we simply say it is on carbon number 2. Now, the double bond there is on carbon 1, the double bond there is on carbon number 2. So the molecular formula is the same, but the structure is not the same. And what makes this structure to be different is the position of that double bond. The double bond there is on carbon 1 and the double bond there is on carbon 2. In other words, the position of this double bond, in other words, again, it is the position of this functional group. It is different, and hence the molecule now, we will say the structural formula are different between the two altogether. And therefore, we classify them as isomers because they have the same molecular formula, but they have different structural formula. And we can see what makes the structure to be different. It is the position of the double bond. Now, when you look at this molecule, actually, this molecule, someone can say, okay, if I want to name this molecule, I can see that it has 4 carbons. So it means it will begin with but. And these carbons, they definitely form the parent chain. Why? Because this is the longest chain without breaking. All the carbons are bonded to each other in a pattern where they follow each other. So the 4, we know the prefix will be but. And again, because I also know that there is a double bond, so it is an alkene, the name has to end with ENE. So this molecule is actually a butene. Now, do I have any other substituent there? And I say no, all of the carbons have been counted. So there is nothing else there which is a carbon that is a substituent. So I'm happy with that. But remember now, you then need to give us the position of that functional group, the position of that double bond, because that double bond, you can actually get it between different carbons, on different carbons, like on this one it's on carbon 1, on that one it's on carbon 2. So we actually need to know what type of a butene are you talking about. So we are talking about a butene where the double bond is on carbon 1. So what do? You just break your molecule there, right? I taught you this to say, oh, it will start with but and it will end with ENE. within. So I put the position of the double bond and it is 1. So it starts with but, it ends with in between I put the position of the double bond, which is the functional group, it's 1. After putting a 1, then I remember there must be a hyphen, which is a dash between a letter and a number. Again, there must be a hyphen between a letter and a number altogether. So the correct name there is actually but1 in. And the entire molecule being correct, you are going to get 2 marks. That is for the IUPAC name. Then this one again, the longest chain without breaking, which is the parent chain, it's but, it's 4 carbons. Then there is a double bond, meaning it's an alkene, so the name will end with ENE. So between the prefix and the suffix, I put the position of the functional group, which tells me that that double bond is on carbon number 2. And I remember the rules again, between a letter and a number, I must have a hyphen. Again, between a letter and a number, I need to have a hyphen. So this one is a but2 in. Now, these are structural isomers, but in essence, we definitely know that these are positional isomers. So if I ask you, okay, I know that they are structural isomers, so tell me what type of isomers they are, or tell me what type of structural isomers they are, then you are going to say they are positional isomers. Why? Because they are organic molecules with the same molecular formula, but a different position of the functional group. So they are organic molecules with the same molecular formula. They are all C4H8, but they have a different position of the functional group. There, the functional group is on position 1, and there, the functional group is on position 2. Now, my dear learners, what if I decided to number 1, 2, 3, 4, meaning what if I decided to number from left to right? Am I still correct? And my answer is yes. It doesn't matter how you number in this case altogether. Why? Because when you count from left to right, this is carbon 1, carbon 2, carbon 3, carbon 4. So this double bond is still on carbon number 2. But on this one, my dear learners, the one on top, you cannot number from right to left, because when you number from right to left, it will be 1, 2, 3, 4. So you would have said that the functional group is on carbon number 3. And by doing that, then the functional group is not on the lowest numbered carbon. So let us test our knowledge. The IUPAC name for the hydrocarbon below is, now let us give a name to this hydrocarbon. You know this structure there, simply put, is to say CH3. So I am here, this is CH3, then I go to this one, which is C. Then this C, I can see that it is bonded to another C, and that C has H, it has H, and it also has an H. So it's that section there. Then I can see that I have a double bond, then I have a C, and this C is bonded to an H. Again, my dear learners, I have a C, and this is bonded to another H, as well as to another H. So that is how the molecule actually looks when it is not condensed. So we need to give the name to this particular molecule. So I have to get the parent chain, which is the longest chain without breaking. So the longest chain without breaking will be 1, 2, 3, 4 carbons, because the carbons are following each other and they are not breaking. Right. Now, why did I number like this? Because if I number from left to right, then the double bond, which is the functional group, is then on carbon number 2. if I numbered from right to left, then it will still be on carbon number 2. But I will show you the problem with that one. So if I number from left to right, the double bond is on carbon number 2, but also this one, which I did not count, which is my alkyl group, which is the substituent, then I can see that it is also on carbon number 2. But if I went from from right to left, well, with the functional group, it will still be 2, but now the substituent will be on carbon 3. So that is not putting the substituent on the lowest numbered carbon. So it is best to then count from left to right. Then I see the longest chain without breaking, it's a bute. So because it's 4 carbons, so it is a bute. And remember now, when you count the longest chain without breaking, meaning the parent chain, it has to include the functional group. Then I can see the functional group is on carbon 2, so it becomes a bute 2. And that functional group is a double bond, meaning this molecule is an alkene, so it will end with ENE. But you can see that here you don't have the parent chain only. You also have a substituent, which is the alkyl group. And that substituent is a substituent with 1 carbon, meaning it's a meth substituent, right? But remember, this is an alkyl group because it's short of 1 hydrogen, so it's not methane. We then call it a methyl altogether. Right, let me just put it nicely there for you. Right, we actually call it a methyl. A methyl. There we go. We call it a methyl. And then remember, you then need to give the position of the methyl. So it is on carbon 2. So it will be 2. And then between a letter and a number, I need to put a hyphen. So the name of this molecule is 2-methyl-bute-2-ene. And that is definitely option C. And we will definitely be awarded 2 marks there altogether. So that is how you deal with your alkenes. Then let us go to our alkynes. Now with the alkynes, we know that the alkynes have a triple bond between carbon and carbon atoms. So very simple, my dear learners. Alkanes, single bond between carbon and carbon atoms. Alkenes, double bond between carbon and carbon atoms. Alkynes, triple bond between carbon and carbon atoms. So how would I draw the functional group? Obviously, the aim is to show me that I have a triple bond between carbon and carbon atoms. So by doing that, you have already won halfway through the structure of the functional group. What are you aiming to show us? You are aiming to show us that if you want to see an alkyne, there must be a triple bond between carbon and carbon atoms. Then what else are you supposed to check there? To say, okay, it is an alkyne, so it is a triple bond between carbon and carbon atoms. Now, I have shown that, but again, I need to remember that for the functional group to be correct, then I need to make sure that around each carbon I have 4 bonds. So because of the triple bond on this carbon, it means I'm short of 1. So it's 1, 2, 3, 4. Because of the triple bond on this carbon, I have 1, 2, 3, then I show 1. So that will be 4. And again, I've been emphasizing this to you, my dear learners, that you do not show the hydrogens. Are we together? Right, because then you would have drawn the actual molecule. Then we go to the general formula. So all molecules that belong to alkynes are defined by the general formula CnH2n minus 2. So you will remember when we were talking about, and I just want to make this easy for you. when we were talking about alkanes, right? When we were talking about alkanes, because I want you to remember how to know these functional groups. Alkanes, you will remember the general formula was CnH2n plus 2. Oh, that one doesn't look nice. Right? It was CnH2n plus 2. Now, when we move to alkenes, what did you see there? You saw that it was CnH2n. So what did I do to move from alkanes to alkenes? I actually subtracted the 2. So the plus 2 was gone, so it became CnH2n. So when I go to alkynes, what am I doing now? I'm doing the same thing. I'm now taking this one and I'm subtracting a 2. So it then becomes CnH2n minus 2. In other words, to go from alkanes to alkenes, you subtract a 2 from alkanes. To go from alkenes to alkynes, you subtract a 2 from alkenes. So the general formula of alkynes is then CnH2n minus 2. Now, how do we name alkynes? Firstly, you can see that we can never have an alkyne that has a prefix meth. It cannot start with 1 carbon. Why? Because we expect to see a triple bond between carbon and carbon atoms. So for alkynes, I must have at least 2 carbon atoms. Are we together? Right. Then I see, oh, I have a triple bond there. So this is an alkyne. So because each carbon must have 4 bonds, then I will put an H there and then I will put an H there. What is the name of this molecule? I check. The longest chain without breaking of carbons, it's 2. So it's F. Altogether. And then because it is an alkyne, it means it will end with YNE. Remember, when it was an alkane, it ended with ANE. When it was an alkene, it ended with ENE. So when it is an alkyne, the name will end with YNE. So the name of this molecule will be ethyne. And remember, what I've drawn there for you is a structural formula. If I want the molecular formula of ethyne, then you just tell me how much of each atoms are there. So carbons, I have 2, hydrogens, I have 2. Now, I want us to test the general formula. Remember, the general formula of alkynes, it's CnH2n minus 2. So I check the number of carbon atoms. So I will say, okay, carbon atoms in this molecule, I have 2. So it will be 2 because N stands for the number of carbon atoms. Then it will be H2. Then I look at my N, it will be 2, which is the number of carbon atoms, minus 2. Then I will say, okay, this should give me C2H. So with the H's, I'll say 2 times 2, which gives me 4, minus 2, which gives me 2, which is exactly that altogether. So it means the general formula of the alkynes in this case is definitely correct. Then we can do the same for propyne. Why is this one called propyne? Because the longest chain without breaking is 1, 2, 3 carbons. So it's a prop. Then I see a triple bond there, so it's an alkyne, so it means it ends with YNE. So why is it just simply called propyne? Because that triple bond there will always be on carbon 1. If I put it there, then it's carbon 1, 2, 3. If I were to take this triple bond and bring it this side, then it will still be on carbon 1. So propyne, basically the triple bond will always be on carbon 1, and hence we simply call it propyne. And the molecular formula, the number of carbons is 1, 2, 3. So it's C3. The number of hydrogens is 1, 2, 3, 4. So it's C3H4. Then for butane as well, right, I want to then show you this molecule. It's actually a butane, but that is not the actual IUPAC name. What is the actual IUPAC name? I will go and I count the number of carbon atoms. It's 4. It's 1, it's 2, it's 3, it's 4. So this will give me but. Then the name is going to end with YNE because this molecule is an alkyne. I can see there I have a triple bond, right? But remember now, this triple bond, it can be here. If it was here, then it would be on carbon 2. It means you must specify the type of butane that you are talking about. And the triple bond is on carbon 1, so I will show that the functional group is on carbon 1. And then after putting the 1 in between the prefix and the suffix, then I'm going to put my hyphens because I must always have a hyphen between a letter and a number, a hyphen between a letter and a number. So the correct IUPAC name there is but1-ine. Why didn't I number from right to left? Because if I numbered from right to left and I said 1, 2, 3, 4, then the triple bond would be on carbon 3, and that is against the IUPAC rules because it wouldn't be on the lowest numbered carbon altogether. Right. So let us test our knowledge. A compound with the general formula CnH2n-2 is A, an alkene, B, an alkane, C, an alkyne, D, a homologous series. Already we see this one, it's already out. But for 2n-2, we definitely know that the correct answer is that it is an alkyne altogether. Right. Now, I want us to move now to alcohols. Now, with alcohols, for now, I wanted to do it a little bit differently. I wanted us to work out the general formula and for us to work out the functional group and for us to give the name of the functional group. Now, let us look at this molecule. Can you see now? It differs from the rest in that now I see an OH. Now, when I see an OH, already I cannot classify this molecule as an hydrocarbon. Why? Because a hydrocarbon is organic compounds that contain only carbon and hydrogen atoms. And now you can see I now have an oxygen. So it means we are actually done with the hydrocarbons. The hydrocarbons are only our alkanes, alkenes, as well as alkynes. Then we say, okay, this one is definitely not a hydrocarbon. So we just know that for a fact. So given a question and they ask us to identify hydrocarbons, I wouldn't choose this one. Then we say, okay, it means an alcohol, we actually see it with an OH group. So this is the functional group. And the name of this functional group, it's actually what we call a hydroxyl group. This functional group, it has a name. We call it a hydroxyl group. So alcohols, you see them by a hydroxyl group. So a hydroxyl group, that is when a carbon is bonded to a hydroxyl group. So how will we get the general formula? How would we then draw the functional group? I would then say, okay, for me to see an alcohol, I want to see a carbon that is attached to an OH. a carbon that is attached to an OH, to a hydroxyl group. And remember, in a hydroxyl group, it is the oxygen that is actually bonding to the carbon, and the hydrogen then bonds to the oxygen. So when I have done this, I have now achieved half of what I need to achieve, because I've shown them that the functional group of an alcohol is when a carbon is bonded to an hydroxyl group. And then I remember that around each carbon, I need to have how many bonds? 4 bonds altogether. And then you are going to get 2 marks. Remember, I do not put my hydrogens, because if I were to put my hydrogens, then I would have drawn the actual molecule, which is methanol. Now, my dear learners, let's say you are given this molecule and they ask you for the general formula. So this is an alcohol, so it means they are looking for the general formula of alcohols. Then I'm going to say the general formula of alcohols, it's going to start just like the rest. It will be CN. Why CN? Because I have carbons. Then it will be followed by hydrogens. And you know your hydrogens will be H. And if I have my hydrogens there, I want to then work out what is happening with the hydrogens. But let me just put the last one there. I also have an oxygen. So I want us to work out this part of the hydrogens. Now, all you can simply do is to check. I have 1, 2, 3, 4, 5 carbons. Okay, so it means this is a, okay. This is actually how I want to do it for you. Because now, let's say you don't recall and you actually want to look at the molecule and work out the general formula. You can see, oh, I have carbons, so it will be CN. I have hydrogens, it will be H something. I also have an oxygen. Oh, there I have an oxygen, right? Then you say, okay, for the H's, so I have CN. And you check your hydrogens. Let us start there. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 1, okay, starting there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, just checked it there. It's actually 12 of them. Ne? So I don't know how I counted this time. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. Then I can actually say, okay, how can I get a 12? What if I say it's H and I say it's 2N? So if I say it's 2N, it will be 2 multiplied by 5. It will give me 10 plus a 1. So it would give me 11 hydrogens. And then I nicely show the OH. In other words, then after working out there, I say, oh, it will be 5 carbons. 2 times 5, it will be 10 plus 1, it will be 11. And then I have an O and the other H there is what makes up my 12th carbon. In other words, the general formula of alcohols is then CnH2n plus 1 OH. So remember that. So you don't go and say, because I know how others work it out. The learner would have said, this is CnH2n, right? Plus 2, and then say O. And yes, it will give you 5 carbons, it will give you 12 hydrogens and 1 oxygen, but this is incorrect. Why? Because we actually want you to show us that functional group there, which is the OH. So the correct functional group is then CnH2n plus 1 OH. And we ask you this because these are examples of recall questions altogether. Right. Then, if it's an alcohol, just like with the other molecules, With alkanes, they ended with A and E. With alkenes, E and E. With alkynes, Y and E. With alcohols, the name actually ends with ol. It ends with OL. So let us look at this molecule and actually try to give it a name. Then we are going to say, okay, the longest chain without breaking of carbons following each other is 1, 2, 3, 4, 5. In other words, I am dealing with a pent, right? And then because I see an OH, I know that the name must end with a ol. But now, my dear learners, you cannot call this name pentol. We include the AN. So it's actually pentan altogether. So it will be pentan. You must include the AN there. Then what is left is, remember when I number, will number 1, 2, 3, 4, 5. Then I will say, oh, the functional group is on carbon 2. Remember, you must always tell us where the position of the functional group is. So this functional group, which we call the hydroxyl group, it's actually on carbon number 2. Then I'm going to put a 2 there to show them that the hydroxyl group is on carbon 2. Then I remember between a letter and a number, I put a hyphen. Between a letter and a number, I put a hyphen. So the full name for this molecule is then pentan-2-ol, right? And I saw there that I definitely do not have a substituent. There's no other carbon that did not form part of the parent chain. Then let us talk about isomers of pentanol, right? Okay. Now, pentanol, if I want to draw it, I could do this. I could say, okay, pentanol, pent means 5 carbons, and then I must put the AN, and the OL tells me that it is an alcohol. So I can say 1, 2, 3, 4, 5. So I want to draw a pentanol. So I have 5 carbons, and then there must be an OH. And let us say I decide that the OH must be there, right? Then what is the only thing left? To make sure that each carbon has 4 bonds. So this one already has 1, 2. So it will be 3, and then it will be 4. On this carbon again, I go, it's 1, 2. So it will be 3, and then it will be 4. This carbon, I have 1, 2 already, so this is 3, and that is 4. On this carbon, I have 2, so this will be 3, and this will be 4. On this carbon, I have 1 bond, so this will be the second one, this will be the third one, and this will be the fourth one. So when you look at this, I have placed my OH on carbon number 1. So what else can I do? Let's try another molecule. Still a pentanol. So still 5 carbons, 1, 2, 3, 4, 5. Then I decide that, okay, I'm going to number 1, I'm going to number 2, I will number 3, I will number 4, I will number that carbon 5, and I put my OH there, right? The only thing left is to make sure each carbon has 4 bonds. I'm sure you know that by now. So I'll just somehow put my H's. There I'm short of 1 bond. There I'm short of 2 bonds. There I'm short of 2 bonds. There I am short of 2 bonds. And there I am short of, in fact, there I was short of 3 bonds. So now I decided to put an OH on carbon number 2. Then let us try another one. Okay, that wasn't nice. Okay, let us try another one simply. We don't actually have to draw that line there. Right? So we have 1, we have 2, we have 3, we have 4, we have 5 carbons. It's still a pentanol. Let us call this carbon 1, carbon 2, carbon 3, carbon 4, and then carbon 5. And let's say I decide to put my OH there. So now it's on carbon 3, then I just make sure each carbon has 4 bonds. So there I need 3, there I need 2, there I'm short of 1, there I'm short of 2, there I am short of 3. So I'll put my hydrogens, 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 hydrogen, 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 hydrogen.
Hi there.
So now, hello?
Yes.
Okay, we are continuing. So if I give a name there, I would then check the longest chain without breaking is definitely a 5. So it is a pent. And remember I said we must include the AN. So it's a pentan. And I know there I see an alcohol, the OH. So this is a pentanol, right? This is again a pentanol. Same thing, 5 carbons, I see an OH, so it is a pentanol. The same applies there, 5 carbons, so it is a pentanol. Why is it a pentanol? Because it's an alcohol, the name will begin with pentan, ends with ol. But now, remember, we have to give the position of the functional group, and it must be on the lowest numbered carbon. Hence, I numbered from left to right. So this one is on position 1. Then I have to put a hyphen between a letter and a number. I have to put a hyphen between a letter and a number. So this name is then pentan 1 ol. When you come to this one, the functional group is on carbon 2. So I'll put a 2 there, a hyphen between a letter and a number. This one, it's on carbon 3, and it doesn't matter how I number. If I numbered from right to left, this will be 1, 2, 3. So this is always going to be carbon 3. Then I will put a 3 there, and then remember between a letter and a number, I must put a hyphen. Now, what can you tell me about the molecular formula here? Remember, the general formula of all alcohols, it's CN H2N plus 1 OH. So if you check the number of carbons there, it will be 5 H, 2 into 5. Remember, N is the number of carbons plus 1 plus 1 as well as an OH. So when I write it in full, it will give me the molecular formula, which is C5H. 2 times 5 is 10 plus 1 is 11. So it's C5H11OH. And you can go and check all these molecules. It's 1, 2, 3, 4, 5 carbons. Then we are happy with that. Hydrogens, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We are happy with that. And then I have an OH. And all of them are C5H11OH. In other words, they are organic molecules with the same molecular formula. So I have the same molecular formula for all of them. But what is different about them? It is the structure. Why? Because the position of the functional group there is on carbon 1. The position of the functional group is on carbon 2. The position of the functional group is on carbon 3. So they are organic molecules with the same molecular formula, but they have different structural formulae. As a result, you can classify them as isomers or structural isomers. And you can even go further and classify them as positional isomers. Why? Because positional isomers, if we just quickly go back to our definitions, right? Positional isomers, you can see they are isomers that have the same molecular formula but different positions of what? The functional group. Remember, it can be the side chain, it can be the substituent, or it can be the functional group. So they are positional isomers because they have the same molecular formula, but the functional groups are in different positions altogether, right? So that brings us to the end of the lesson. Tomorrow we will be continuing with other homologous series. So we are nearing nomenclature, and I think we are doing quite well. So tomorrow we will be dealing with ketones and carboxylic acids, etc. If you've just joined us, remember that to prepare for the examination, nomenclature itself will be plus minus 29 marks, but the topic altogether, it will be 85 marks. So that is all I had for you today in preparation for our class on Saturday and so on, which is the question and answer session. Send me questions to STEM Digital School at africa10gigs.co.za. Thank you so much and have a great evening. Goodbye.